Okay, we're here finally. Okay, um, so I had slides from something I had done before, and then this morning I woke up and decided I hated them, so I redid it today. Of course, when I don't have school, I don't get up till 11 o'clock, so it was after that. But anyways, so what I'm going to talk about is engineering and manned space flight from my perspective. And the reason I add the old woman's thing is because I think in particular engineering has changed hopefully a lot since when I started. So I'll just throw that out there. So the first thing I remember of manned space flight was in May of 1961, and I was sitting in first grade, and we didn't have TVs there or anything, but over the intercom system, we got to listen to Alan Shepard, who was the first American in space, and I remember just being so excited about it. So then 1964 came, I was 10, and I read a book about going to the moon and decided I wanted to be an astronaut. Now it was a little suggestible because like the year before I had read a book about nursing and I wanted to be a nurse. And a couple years later, I read a book about the discovery of the ancient city of Troy, not that Troy, New York City, and wanted to be an archaeologist for a while. But I stayed with the astronaut thing for a little longer. And one of my next big memories was in 1967 when the first Apollo capsule was getting ready and 3 astronauts died in a fire on the launch pad. And at that point, they would break into TV shows with breaking news, and they talked about it. And it was always pretty scary when they would break into TV because it meant something not very good happened. So the next big thing, though, was the first manned mission to the moon, Apollo 8. And the astronauts in Apollo 8 were the first ones to ever see the backside of the moon. That was pretty cool. And then in July of 1969 was the first moon landing. And it was like a huge deal. My dad woke us up so we could watch the first steps on the moon. And, we didn't have like DVRs or anything like that then. So I recorded the landing on the moon using my sister's tape recorder. I don't know where that tape ever went, but it was just like a huge deal for me. So I go to high school, and in 1971, I tell my guidance counselor that I wanted to be an astronaut. And at that time, I think most guidance counselors would have sort of laughed at a young woman who said she wanted to be an astronaut. But my guidance counselor was awesome, besides being really, really handsome. And he said I should become an aeronautical engineer. I had no idea what an engineer was, but if he said that's what I should be, I said, okay, I'll become an aeronautical engineer. So in 1972, I started college at RPI. In 76, I graduated with a BS in aeronautical engineering. I decided I didn't know anything about engineering, even with the BS, so I decided to stay for my master's, which was going okay till my thesis failed. So I ended up leaving before I had my master's. But I did start work at Hamilton Standard, and they've had like 4 or 5 names since then. But when I started, it was Hamilton Standard. I worked in the Space Systems Department, and I was a mechanical design engineer. And our claim to fame there was that we provided environmental control and life support equipment for manned spacecraft, including the spacesuit. So for the first 6 months I was there, I worked on the spacesuit, which is the EMU, or extravehicular mobility unit. But after that first 6 months, I went to work on the space shuttle systems. And in April of 1981, there was the launch of the first space shuttle. So here's a picture of a shuttle launch, because it was cool. I did get to see 2 shuttle launches, which was pretty exciting. But the picture on the right tells you this picture is really life support as opposed to environmental control. Environmental control is temperature control and things like that. But for life support, hold on. Hey, can I call you back? I'm in the middle of something. No, I'm not. No, I'm okay. Bye. Okay, bye. Sorry about that. You can hear me, right?
Yes, we can hear you, Donna.
Okay, I just wanted to make sure. Sorry. Okay. That was my state rep on the phone. I didn't want to just ignore her, but but life support is talking about stuff you need and stuff you have to get rid of. And, you know, you need to eat and you need to drink and you need to take in oxygen. But you know that when you take in oxygen, you breathe out carbon dioxide. So a big thing is you have to take carbon dioxide out of the air or people would asphyxiate. You know, when you breathe out humidity from your mouth, you perspire. And same thing, if you didn't do something with perspiration and that humidity, you'd have water all over the cabin. And the other two things you send out are urine and feces. And that sort of leads to the one thing I worked on that people loved above everything else, and that was the space toilet. So I'm going to spend some time talking about space toilets because it's the most fun. So I don't know how many of you ever watched Big Bang Theory, but Wolowitz designed and his friends built the zero gravity waste disposal system, which is a pretty funny thing to somebody who's actually worked. Nothing is ever designed by one people. It's and built by their friends. There were probably 100 people that worked on the space toilet when I was working on it. I was the lead design engineer on it, but there were leads in all other disciplines. And so anyways, I loved that show, but this thing annoyed the heck out of me. So this is a picture of the actual toilet that I worked on. The picture on the left shows it installed in the shuttle, and the picture on the right just shows another view of it. And the way the toilet works is, you know, you're on the ground here, and gravity does most of the work for you. You pee, and the pee goes down into the toilet. You poop, and the poop goes down into the toilet. In zero G, nothing goes down, everything floats. So if you peed, it would float around. If you pooped, it would float around. And the original shuttle toilet was interesting in that you can see, I don't know if you can see my cursor. In the front here, there's a hose with a funnel, and that's where you pee into the funnel. And there's a fan on the inside that will draw the urine into the system. And that's pretty common with every toilet. The Russian toilet that's on space station now does that. The original shuttle toilet did that. It's just, that's how you collect urine. It's the feces collection that's a little different. In the original toilet, they had airflow again that would draw the feces in, but then they would open it, they would close off the lid, and they would open it to the outside, and it would freeze dry, in essence, freeze dry the fecal material, which left a lot more room because there's a lot of water in feces. But they had failures also where they'd open the lid and there would be fecal dust floating around the cabin. So that wasn't overly popular with people either. So the way this toilet worked was you'd lift up the lid and you'd put a bag underneath, and you'd actually go to the bathroom in a bag. And you'd put a lid on the bag, and then this thing that stands up in the back is a compactor. So you'd swing the compactor over the lid, and it would actually compress the bag into the bottom of a canister that you can't see in here. And it would pile up, and you'd be able to, you know, go like 20 times in a canister, and then you'd take the canister out, put a lid on it that contained odor and bacteria, and you put a new canister in and you could start all over. So that was, a pretty popular thing. In the probably around 2008, I went to a design review and I happened to meet an astronaut, Mark Kelly, at this, and we'd have astronauts would come to our presentations for different things, and he was there, and in between talks, we were having a break, and he got me and said that, he had never used this toilet, but that all of his astronaut friends really liked it. So that was, pretty good story. What's interesting, Mark Kelly is now a senator from Arizona. His wife was Gabrielle Giffords, and she was the congresswoman who was shot, which happened several months after I had met him. So that was one of my astronaut encounters. That was interesting. And again, he had nice things to say about the toilet. Here's a picture. On the left is like the original shuttle toilet. And on the right, this is a mock-up, but it's pretty similar to the existing one. And one of the things you'll notice is the size of the hole in the toilet seat. And the astronauts absolutely hated the little tiny hole. So at that point, before they would go into space, they had to practice using the toilet, and they had to practice centering their anus over that little tiny hole that was in the seat. And the way they did that is that there was a camera at the bottom and a monitor up on the wall so that they could watch themselves sit on the toilet seat and get the feel of what it felt like to be sitting in the correct location on the seat. So that's one of the things they really didn't like. And so our goal was to make a much bigger opening in the seat, which we did. And that was pretty popular. And the other, worked on almost all the shuttle systems. That was the most interesting. So in the early 90s, I started working on subsystems for the International Space Station, although at that point it was called Space Station Freedom, but then they decided it was going to be too expensive. So they got international, other countries to become part of it and renamed it the International Space Station. And the first long-term residents arrived in 2000. So here's just a picture of the space station. And this is a little flow chart of environmental control and life support systems in the space station. So up in the upper right-hand corner, during the original launch of the original assembly of the space station, it had things like temperature and humidity control. So again, you have to, it'll tend to get hot because you have a lot of machinery that produces heat. So it's actually harder to cool it down than you would think. And you also have to remove humidity from the airstream. So that's always in place. There's carbon dioxide removal. And they would originally they would overboard vent the carbon dioxide. Now there's a system called Sabatier, which actually will remove the oxygen from the CO2 so that you're not throwing that overboard anymore. Another thing that is always in there is trace contaminant control, because there's always things like ammonia and alcohols and stuff that are in the air that you don't want, so it has to remove that. And I worked on all of those things. There's also, and when it first launched, or when it first became manned, they would bring up bottles of oxygen and nitrogen. Since that time, we've provided an oxygen generator that takes water and breaks it down into hydrogen and I mean, it takes water and breaks it down to hydrogen and oxygen, and the oxygen is used for breathing. So again, they don't need to bring up bottles of oxygen anymore. And the other big thing, and this is the thing I really worked on later on in my career, was water processing. And again, originally would have to bring up big tanks of potable water. And it costs a lot of money to launch things. It takes a lot of space to bring up big tanks of water. So, and this was always a plan, it just wasn't in the original framework, was to be able to do water processing and use that water for everything. And part of the water processing is using recovered urine water. So they collect the urine and break it down, and then they send dirty water to the water processor. Humidity condensate, the thing they're taking out when they do temperature and humidity control, gets sent there. So any wastewater gets sent to the water processor, and it changes it into drinking water. Now, I don't know if can you see this?
Yes.
Okay.
Yeah, we can see that.
Okay. So this is a bottle of reclaimed water, and the water processor was launched on November 14th, 2008, and a whole bunch of us people that had worked on it went to the launch. And as part of it, they gave us bottles of reclaimed water. And since that was right before Thanksgiving, we had it as part of our Thanksgiving dinner in 2008. And at that point, one of my sisters and my mother were totally opposed to drinking reclaimed urine water, but when everybody else drank it and was fine with it, they even had some. So that was one of the high points, drinking reclaimed urine water. So this is a picture of the water processor and the urine processor. So the urine processor is in the left-hand rack, and what these go in are called racks. It's the left-hand rack, the left-hand side of that, and the very top of the right-hand side. Everything else is part of the water processor. And I spent a long time working on that. It was very interesting. I learned a lot about keeping water clean, keeping bacteria from growing in water. Some of the things I learned on that have helped me in the whole understanding COVID and how COVID spreads and things like that, because we had to look at stuff like that. I mean, we didn't look at COVID, but you have to not have bacteria or viruses in the water. So that was a really interesting program, and it got me to a launch, so that was pretty much fun. So the next thing that I really worked on was the Orion program, and officially the name right now, because it's changed names, sort of like the space station, is the Orion Multipurpose Crew Vehicle. It's a shuttle replacement, except the shuttle could only go into Earth orbit. The Orion is for use in deep space, like going to the moon and Mars. The first unmanned launch was in December 5th of 2014, and I just checked today to figure out when they have the actual manned launch, and it's 2023. So I just wanted to point out that I started working on this in 2005, and it's 2021, and we still haven't had a manned launch, which is a little disappointing when you think that the United States started working on a space program in like 1960 and landed on the moon in 1969, and they knew absolutely nothing about anything when they started this program, but it's going to take us, twice as long, and we had all the history. So it's been sort of a disappointing turn of events. So here's a picture of what an Orion spacecraft looks like. In the middle is the crew module, and that's where the people are. And if you've ever seen any of the either Mercury, Gemini, or Apollo capsules, it's very similar to those, just a little bit bigger. It does have on the right there a launch abort system, which if there's an issue with the rocket as part of the launch sequence, it actually can pull the capsule off of the rocket and put it in a different direction so that hopefully, you know, the crew members could survive an issue. And in the back end, there's a service module, which is mostly provided by the Europeans. This is a couple of pictures of the assembly of the first Orion spacecraft that did a, you know, unmanned launch. And I worked on stuff, or my company and I worked on things inside the crew part and then outside. And I was having trouble figuring out which of these might have been stuff that my company provided, because they'll look sort of the same here. But so this was, a bunch of us did go to the launch of this also. So the picture on the left is a picture I took of the rocket. So you're not very close when you go to a launch. Although once it's taking off, that distance seems to disappear. On the right is a picture of me, a couple of my friends from RPI, a couple of my roommates and their families, and then one of my sons and my daughter-in-law and my granddaughter. So we were all able to go to the launch. The picture on the bottom right is us recreating our excitement at the moment of the launch. So this was after it, but anyways, we were pretending that we were still excited. So launches are always interesting. So the launch was supposed to be at 7 in the morning, which meant we had to meet the NASA bus, which would take us into the launch area, because we were able to watch it at a special area that, you know, NASA controlled. So we had to get to our pickup point by 2 in the morning. So we got up really early. We had to get there for 2 a.m. Then we get to the launch place, and it's supposed to take off at 7, and everything's going great. And like within a minute, the minute they had started counting down, we had a hold because there was a boat that came into the area where that you're not supposed to be in case, again, there's an accident with the launch. So they did a hold. So they went and got rid of that boat. So they started again with a countdown, and they go back a little bit and then they go forward. And then they had wind gusts, and the wind gusts were too high. So the wind slowed down, and then they restarted the countdown. And then again, another wind gust that was too high. And then that slowed down, and then they started again. And again, with 3 minutes until launch, they had a valve that did not close. So they scrubbed the launch. So after getting up at, you know, meeting our bus at 2 in the morning, the mission was scrubbed, and we were pretty bummed. We went to a celebratory breakfast, and of course there wasn't much celebration because it hadn't happened. Anyways, so the next morning, we get up and have to meet the bus again at 2 a.m. By then, my granddaughter was having none of it. She wanted to just stay in bed, but we made her come anyways. And that one, I am sure that the wind gusts were the same both days, but they launched anyways. So let's see if this is going to work. This is, and I wanted to show this. It's probably not going to be as exciting for you as it is for me, because every time I watch this, I still tear up. But anyways, let's see how it works.
T-minus 1 minute.
Engine start box, go.
Rock, report range status.
Range green. 50 seconds.
And don't forget, you know, we were at this
45.
point sort of when we kept getting hold, so we're still nervous.
40.
Upper stage LH2 secure at flight level.
35. 30.
Status check.
Go Delta.
Go Orion. Grain board.
25.
Flight lock in.
T-minus
20 seconds.
15,
Rough ignition.
10,
The igniters have been lit.
9, 8, 7, 6,
5, 4, 3, 2, 1. And liftoff at dawn. The dawn of Orion and a new era of American space exploration.
Good engine control on the first stage. Passing 25 seconds. Velocity 1,341 feet per second. Passing 31 seconds, still looking good. Good engine control. Good chamber pressure in all three boosters in the full power mode. 40 seconds in. Standing by to go to the partial thrust mode in the core.
T-minus 1 minute.
Engines.
What's interesting about launches, and I've been to 2 shuttle launches and then this one launch, is you can see that it's happening. You see all the fire and the smoke, and it's seconds before you actually hear the sound, and the sound is deafening, and you get the wind that's created by it. And the launch area is about 3 miles away from where the launch is happening. So it's definitely a discernible difference between when you see it and when you hear it and when you feel it. And it's pretty cool. And this is really my last slide, is just so you can see. So these capsules come back, and they come back, and you can see at where my cursor is on the right, belly forward, and it's covered by tiles, and the tiles are what keeps it from burning up. And so it looks pretty darn good, you know, lovely, shiny before you launch, and it doesn't look nearly as good after it comes back and bounces in the ocean and stuff, but it's mostly the fire. And I'll just say I retired on December 31st of 2017, and before we ever had another flight. So that's, I worked on other stuff in between, refused to work on a couple things because I didn't like them and stuff, but.
That's so cool, Donna. It
Yeah.
is so cool.
I do want to tell you, when I was my last 2 years at RPI, George Lowe was the president, and he had been deputy administrator of NASA during like the Gemini and Apollo programs, and he would be the person on the when you would hear the people talking from NASA during launches and stuff. And at one point I went to something, I don't remember what it was, but I met David Lowe, George Lowe's son. And I said, oh, I remember your father. And he had died by then. He died pretty young. And he goes, well, you can't be old enough to remember him, which was like really a high point for me. And I said, well, I do remember him. But I said, I also went to RPI when he was the president. But anyways.
Well, and my college roommate went to RPI to be an aeronautical engineer like yourself. And she ended up working for NASA down in Mission Control in Houston. But she always talked about Gene Kranz.
Yeah.
She goes, I want to meet Gene Kranz, with the guy with the white vest in Apollo 13. So if you guys haven't watched the movie Apollo 13, you should, number one, because it's a fabulous movie and it's all true. But the guy in the movie, Gene Kranz, was the NASA mission control person in charge of those missions. And I know when I just started teaching, I was in my first year of teaching. She was at Houston in mission control, and she said, come down and visit me. So I got to go into mission control, and I have the pictures to show it. And I snuck something out of the mission control room. The cover of the flight manual, the mission, they always have a binder with all the stuff for the mission, for the Apollo 11 mission. I have the cover to it. I was told, make sure I don't put it on eBay because the FBI may show up at my door for stealing property from the federal government. But
Well, when I was applying to college, one of the places I applied was MIT, and I went there to visit, and I met the woman who had helped choose the Apollo 11 landing site. And that was pretty exciting for me and, sort of a plus for going there. But then I got in, but they hardly gave me any money. So they were okay with me going, but they weren't going to give me very much money to go. And RPI gave me the most money. So my dad said that's where I was going. Of course, then the next year they cut it in half. So, but anyway, it worked out. It worked out. But
So kids, what questions do you have for Donna?
What's your perception or what do you think about private companies wanting to do space exploration, such as SpaceX, like their shuttle exploded upon landing? So do you think that they're genuinely curious or just wasting money aimlessly?
I don't think they're wasting money. I'm going to say, working with NASA, when I was working, I was totally, anti SpaceX. But I have a son who loves space stuff, and he's a huge SpaceX supporter. So, but now that I'm gone, I can look at it differently. And I'm going to say one of the things, I complained about the fact it'll be 20 years before there's or almost 20 years before there's a manned Orion launch. And part of the problem is that what they do now is test everything. Well, no, you don't start out testing. First, you do paper, and the tons and tons of paper. I have created so much paper for things that we haven't built yet. And then you finally build it and you do a lot of testing. What a company like SpaceX does is they build something and try it out. And it turns out in the original space program in the 60s, that's what they did. They didn't know anything. So they built stuff and they tested it, and the things that worked, they kept. The things that didn't work, they didn't keep. And so I can appreciate the SpaceX doing it. And they know when, because one of their big things was they wanted to be able to reuse the rockets. So, they launched, they bring the rockets down, and the first bunch of times they did it, it would blow up. However, they do it very consistently now, and it's trying it and practice. And I definitely have, sort of a soft spot for them now. And so I think they probably could use a little bit more analysis than they're doing, but certainly NASA does way too much analysis of stuff that they haven't built. Because even once you do that, when you first build something, it doesn't work. You still have to do a whole bunch of tinkering with it. So we waste so much time creating paper. And yeah, so SpaceX, and like Boeing's doing one, and it's called commercial. There's, Boeing are the people that were the primary contractors on the space station. So it's not like they're a company like SpaceX that is really a commercial company. And NASA does fund all of them to some extent. They fund, and then, but the whole point with the commercial is at some point, these companies will be able to charge people to, to bring up a satellite or whatever it is that they want to do. So yeah, it looks like they have a lot of failures, but I think it's because they're trying stuff out and they don't try to hide it, which I give them credit for. So it's a good question.
All right, who's got another question? I think my dog has a question, but I'm going to get him to be quiet, give him a treat. So who's got a question? Somebody's got to have a question before Billy says he's got to do something. All right, I want to ask this. So you said you did a lot of paper.
Yes.
And see, I was the biomed engineer before I went into teaching, and we also had a lot of paper because it influenced, things I built were being implanted in people, or, but I didn't want to kill anybody. And a lot of that was government mandate.
Right.
So I guess what I'm kind of wondering is, do you see this in lots of different forms of engineering, or is this really just like with things involving the government?
Certainly, I think everything involving the government is worse or more so. I, I suspect everybody does an amount of paper engineering. The Russians did like no paper engineering. At one point, it was probably in the late 90s, we had a Russian contingent come to where I work to talk about their life support versus ours. And they do like no analysis of anything. And they built everything without analysis. And that was part of the reason they never made it to the moon, was because they couldn't afford building everything and having it fail. So again, there's a happy medium between doing enough and doing too much. You can't afford to build everything, without doing enough work. And they had early success, and they really fell off. And it was primarily money driven. So, and I'm sure that SpaceX is doing a lot of paper too, just not as much as NASA would make somebody do. I know a couple people who worked for SpaceX, and they were and it was all younger people, because they would just pretty much hold them hostage, and they were working, 16 hours a day, every day, and only younger people would put up with it for that much. But it was a good education for them. They loved it, but it's not something you can keep up. But so they did paper too, just not as much. But I will say, with my 4 fake knees, I'm happy that people did a lot of work on, body parts before they.
FDA, thank the FDA on
Yes.
that. So I want to ask you this too, because the last part of your presentation was about Orion.
Yeah.
Going to Mars, and now it's been pushed back to 2023, the human manned mission. There's still quite a bit of controversy, as to whether we'll actually be able to get humans there. You think
I'm sure we can get humans there. I don't. It's a long flight, 9 months to a year to get there, and so, it's not something you do lightly. It's,
and it's, from what I hear, it's a one-way trip, right?
It doesn't have to be.
So is that
I think it depends who. It's a lot easier to take off from Mars, because the gravity is so much less. I think it's SpaceX is talking about, going to Mars. I believe theirs is a one-way trip. I'm not sure that the United States would ever just do a one-way trip. But
yeah, because I wasn't sure. I know, like, when you showed us the launch of Orion.
Yeah.
That's got all these large rockets attached.
Yeah.
And obviously you don't need quite that many to get off of the surface of Mars, but we haven't been able to lift, even our rovers can't come back. So
but they're not made to come back. They don't want them to come back. So I think that's part of it.
So are there like miniature rockets and things on the Orion craft that would get the astronauts back?
It wouldn't be Orion at all. Orion is just the capsule and the service module. So even the Orion rocket sets have changed. It was one thing when we first started, and the thing they were doing wasn't working. So now there's another set of rockets. And that's part of the reason it's a little behind, is they switched rocket technology. The Orion launch was actually an existing set of rockets, the Delta IV Heavy, and those were not man-rated. So it was okay to use for a non-manned launch. But when you put people on it, the amount of testing and stuff, it goes up exponentially because there's people. So, and I'm going to be honest, I'm not clear what the plan is, but they were able to take off from the moon again. When the amount of gravity, and what you'd probably have would be more similar to the moon, where you'd still have something in orbit that whatever landed would made up to, and that would have the big rockets to get you home, is my guess.
So not like The Martian. The
Well,
movie.
Well, The Martian was sort of like that, I think. Well, except for all the failures, but
Right. Hopefully.
yeah. It was interesting watching that, because a lot of the stuff that he did while he was there is stuff I've heard about. And so, there was a lot of fact-based stuff in the things that he was doing to keep alive. So I thought that was interesting. And he's so adorable.
Well, Matt, I mean, how can Matt Damon not be
I know.
adorable? Okay, who else has questions? Donna, how many women were in your engineering classes?
Well, most of my classes, I was the only woman. When I was there, the number of men to women was 13-1. However, most of the women, even in my class, were not in engineering. There were a lot in biology and the other sciences and math. So I think that in my class that was like 1,000 people, there were 700 engineers. I think there were 10 women engineers when I was there, and the other women were in other fields. I know several people who end up going to medical school and are doctors now and stuff. So what was pretty interesting, though, of those 10 women in engineering, 3 of us were in aeronautical engineering, and all 3 of us wanted to be astronauts. So that was, and one of them, actually, none of us were astronauts, but one of them works for NASA, although she's on the verge of retiring, but she works at Langley.
Okay.
Yeah, so. And then, when I started work, it was much the same. When I started, my department was like 1,000 people, space systems. I was the 3rd woman engineer. I was the first one in my group of mechanical design. The 2nd woman in my group started 7 years later. So it was a long time coming, and it was weird. There were 2 types of people when I was there. Originally, things have changed a lot. They're not perfect, sort of like society in general. But most of the guys in my group were really nice. They were all older, and they sort of treated me like I was their granddaughter. So that was really nice. But there were definitely other people who were not happy that there was a woman in engineering, and they made it very clear that they weren't happy with that. So it was a weird thing when I left to have my first kid, which was sort of an accident that I got pregnant. But anyways, I did. And most women, even, there were women in finance and women, secretaries and stuff like that. Well, pretty much when anybody had a baby, they left and didn't come back. And I was still paying my school loans. I was coming back to work. There was like just no option besides going back. They didn't know what to do. They had no idea how to handle a woman leaving and planning to come back. So that was a big thing. When I did come back, they made me come back sooner than I wanted. And then, like, right after I came back, I got my first performance review, and they didn't give me a raise because I took a maternity leave. And it said that in writing, which I kept for many, 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 many years, because it became ammunition and I'm going to say afterwards, a whole bunch of women have left to have babies, come back. They've got really nice maternity leave plans now. Fathers get paternity leave. And so that has really improved. But again, part of it is there just need to be enough women involved to make them see the error of their ways. So that was a pretty interesting thing. I had to threaten them with the Civil Liberties Union, and then they were afraid of me. And that was actually my most successful, was making them afraid of me, which isn't really what you want to be, but if it works, it works. So.
Well, absolutely. And I know there's a lot of young women here on the on the
Yeah,
news
so that was
today.
why I
So,
was bringing it up. I will say, I learned a lot of engineering, a lot of technical things working. The biggest thing I learned was that you have to stick up for yourself. And, my feeling always was, you work hard and they'll like you and you'll do well. That turned out that wasn't the truth. The truth was, if I didn't stick up for myself, they were just willing to not give me good raises, not promote me, any of that stuff. And so, again, a big learning for me was, if you don't stick up for yourself, nobody's going to. Anyways, and yeah, yes. It's for sure. And, and it worked, because as time went by, obviously I got better at engineering. I was awful when I started, and I fully acknowledge that. But, as I got better, and I got where every time they had a new job, people wanted me on the new job because I got good at it, and that's what I was good at. So, you can get the recognition and stuff, and customers loved me for some reason, mostly because I fancy myself to be really funny, and I don't know if they're just laughing at me or whether they thought I was funny. But so I worked on a lot of neat programs, and I would always get on the ground floor, which is always more fun at the starting off stuff. So, but yeah, definitely stick up for yourself. Even if you're shy, I was extremely introverted at that point. I've mostly gotten past that, not totally, but I couldn't. I remember I was complaining to one of my girlfriends about the no raise thing, and she finally said, "Stop complaining to me and complain to somebody who can do something." And that was really what opened my eyes. So, yeah.
well, and I think, at least from what I'm hearing from former students who are now in engineering, things have changed a lot, but not 100%. So there's still room
Yes.
for improvement.
They,
But you gotta get more women in there, and then it will change.
yes, and the Orion program was ended up being terrific, because there ended up being a lot of women on it, and I would go to meetings where it was only women in the room, and it was like, compared to when I started, and most meetings had no women, or I was the only woman. So that was like really good, and turned out women were really organized and got along better, and didn't try to steal credit from other people. So it was a really good thing when that happened, but it was a long time coming. And, I had young women work for me, and I had to do things for their benefit, because there's still things like sexual harassment would happen and things like that. So, that stuff hasn't gone away, but.
All right. I have to say, I think, I don't know how you kids feel. The presentation about the toilet, I thought was hysterical. Okay. I could not stop laughing. I haven't laughed that hard in a while. So thank you. But I know that it's my friend who was at Mission Control. She was working partially. She talked about the ISS recycling the water.
Okay. What's her name?
Christine Terrell. At least she was Christine Terrell when I knew her.
Okay.
And I know she's married now, so I don't know if she changed her last name. And I don't know if she still works for NASA, or if she's moved on to another company down in Houston, or if she's even in Houston anymore. We've kind of lost touch, and that's one of the sad things. I'm trying to find out where she is nowadays to see what she's up to. But I know that she often talked about that. And there's a movie I've shown my students before. Selma, do you remember me showing the movie about the ISS in class, the IMAX movie? We watched, Tom Cruise narrates the IMAX movie about the ISS. It's called Space Station. And he talks about how the water has to get recycled. And I don't know if I told your class, Selma, at that time, my cousin, I know the person who worked on that. But it's always, the kids are like, what does that mean? The water has to get recycled. I said, well, what do you think it means? It's like, come on.
Well, originally, when we first proposed on it, there were going to be two water systems, and one was called the hygiene water and one was a potable water. So they would use like the reclaimed urine water would only be for hygiene water, which would be like washing up and stuff like that. And then it just was too expensive. And, every year, at least every other year, sometimes every year, we would be threatened with a cut in funding and that they were going to cancel the program. So they were always looking for ways to save money. And that became one of the ways, was just to have, the water was going to be equally clean. I mean, there's all testing, there's sensors and stuff that test the water. They also put it into bags first, and then they test the water in the bag before anybody drinks it. So it's, it's fine, but a lot of it is just a mental thing. And, and it tastes awful because it has iodine in it, because it's so clean. The water you get out of your faucet, or if you buy bottles of water, it's not as clean as this water. So it has no taste. It would have no taste, which would taste funny to you. And then they put iodine in it to make sure that that no bacteria or anything can grow in it, because it doesn't take long for water to get gross. So, it just doesn't taste very good, but.
I think they learned a little more about it than they even knew could be. But if you think about it, how do you do that in space? I mean.
Yeah, and the other, what was interesting, and they found this after the earlier missions with the iodine, is that people were having medical issues because of iodine. So now they actually typically will take the iodine out so that it's not an overdose of iodine.
That's Billy. Don, I'm sorry. Billy's being. He interrupts all our STEM meetings, and I'm not sure why he does that. Anyone? I don't want to keep Donna on the call forever, but do you guys have any questions for her? All right. Well then, folks, let's give Donna a big thank you for talking with us tonight. I hope you all learned something. I know I did. And it's not easy for me to learn things anymore. They think their teachers know everything. We don't. So I learned a ton, and I appreciate that I kind of harassed Donna a little bit to do this presentation. So
you learned about going to the bathroom with no gravity. It's a very important thing. Very important.
Well, it is. If you're one of those astronauts, it is.
It is. And again, I worked, on stuff for 40 years. The only thing I ever got questions on from the relatives was the toilet. That's what everybody was interested in.
I know, it's why my mom always said, she designed the toilet. Like, she did the toilet? I gotta say, after that presentation, I know why your kids, I know your kids, so I know why they are
they have no problem talking about going to the bathroom, right?
No, exactly. Well, nothing is off limits in terms of topics of conversation.
Well, what's funny is when I was in first grade, I had to go to the bathroom, and I was way too shy to raise my hand to ask to go to the bathroom. So I wet my pants. So wetting my pants was preferable to asking to go to the bathroom. And so, forward, 30, 40 years, and I'm in front of a room full of like 300 people at NASA, a bunch of astronauts and stuff, talking about going to the bathroom in space, and it didn't bother me anymore. But that was like a quantum step for me, going from afraid to ask. And I got to the point where every time I was in a meeting and I had to go to the bathroom, I'd say, "Can we end the meeting? I have to pee." So people... I definitely got past the whole peeing thing. So,
all right, kids, you sure you don't have any more questions? This is your chance to ask a space engineer anything that you want to know. All right, Tyler, what's your question?
So, weird question, but can you technically double as a plumber since you've worked on the space toilet?
So funny story about that. While I was working on the toilet, I had an issue with my toilet in my, in my bedroom upstairs, or, the one that, and I fixed something. So I go to work the next day and I'm like, I fixed my toilet. And somebody says, he might not want to say that so loud because, if there's any customers here, they might really wonder about how excited you are about fixing your ground toilet anyways, but so yeah. No, I have a plumber that when I have issues, I call him, he's in my phone as Tom the plumber, so.
Nothing else? Anyone? Anyone? You can type in the chat if you're afraid to unmute. I don't see anything coming up. All right. Well, Donna, thank you.
You're welcome, and hopefully I can see you in person soon.
I hope so. And I said next time we can get you, if I can get you out here at some point, we're going to dinner.
Okay.
That's for sure. If you get vaccinated, well, you're on your way. I'm there. We can do this. So
Okay.
we'll get together. But all right, they're all writing their thank yous in the chat. I don't know if you could see that. So
Well,
I hope you all enjoyed tonight's meeting. I just want to tell you our next one will be in 2 weeks. So no meeting next Thursday, but one the Thursday after that on the 18th. I think it's 4:15. Is that right, Charisse? 4:15? Yes, she says yes. So it's 4:15 on the 18th. Okay, folks?
Real quick, Ms. Famoso, should we mention the April 1st
Yeah, go for it.
meeting?
Go for it.
Oh, you want me to? Oh,
no, yeah, because I have nothing to do with it.
so,
That's all up to you guys, remember?
Yeah, so obviously any of the other officers, if you want to step in, please do. But essentially on April 1st, if you have a topic you would like to research in depth and kind of like present to STEM Club that's STEM related, yeah, we'll let you do that for like April Fool's Day. It's not an April Fool's joke. We're just going to let you do it. So we'll have like a Google form or something like that, right, everyone? We'll have like a Google form for you to sign up. Then you can do your Google Slides presentation. You can share it with all of us. We haven't really decided like a time limit for how long the presentation has to be. I would probably say no longer than like 15 minutes, just so we can get through as many as possible. But yeah, is there anything else? Am I forgetting something?
I don't know. That was because I had said I was leaving that up to you and Tahira and Selma and Hilbriel and India and to figure that all out.
The other officers had any ideas about it. So I'm good with whatever we end up doing. So just keep on the lookout for that, for like a Google form for that. If you have any questions, feel free to contact any of the officers. And yeah, hopefully we'll get that out probably by like this weekend, and then we can actually have something tangible and we can, decide which people are doing which presentations, how long it's going to be, et cetera, et cetera. So yeah, I think that's good though.
Yes, it is. Yep. So we got to get that out this weekend. All right. Oh, who's that? That's Grace. You got your hand.
I just had a question about our next meeting. Do you know who the speaker is going to be on the 18th yet?
Yes, the speaker is Ronke Asipitan. She is a Colony grad. She is working right now on a degree in computer science. She's, I think, master's degree candidate at SUNY Albany, but she's a computer scientist. And she graduated from Colony, oh, geez. I had her as a student maybe 7 years ago or so. But she's working on her master's degree right now in computer science. Some of you may know her sister. Tyler, what was her sister's first name?
I think her name's Tola.
Oh yeah, Tola Asipitan. She was a more recent graduate. She graduated just a couple of years ago. So if you knew Tola, then this is her older sister, Ronke. And she's been at SUNY Albany studying computer science. So we thought it would be great to have her come in and talk about another area of STEM. Last week we had a marine biologist, Donna, join us from Nova Scotia.
Ooh.
Yeah, which was pretty cool because he even was saying there's no COVID in Nova Scotia. Which is
I have planned like 10 trips since COVID started, since I can't go anywhere. And Nova Scotia was one of the ones I planned.
Yeah, and they won't let us in there. And he was saying,
No,
yeah, because we've had like 3 cases since this all started. 3. But so he joined us last week. And now you're our second one. And now we're going to have, we have pretty much every week after that, we have lined up a guest speaker for the rest of our school year. So it's pretty exciting, but they're going to get to hear. So Grace, you'll get to hear from Ronke Asipitan, computer science. So, and she was I'm not sure why she chose computer science. I know she took a computer science course with Miss Eicholzer when she was in high school, but I don't know if that's what steered her in the direction of studying computer science, but those are all, that's a question I have for her because she was a physics student of mine. I want to know why she didn't go into physics. But so I hope that answers your question. And I think the weekend after that, we have Professor George Harrell from Siena College joining us, and he's from the Physics and Astronomy Department at Siena College. So he'll be joining us talking about their programs and that kind of thing. So
my son Adam was a physics major at RPI, right?
I did not know he was physics. I knew he went to RPI. He's the one who's got the app, right?
Yeah, well, he doesn't own it anymore because he sold it to Apple. So
you got to tell them about that app because I bet you some of them have it on their phone.
Right now, you have to have an iPhone to have it, but it's Dark Sky, which is a weather app, and so yeah, Apple was after him to buy it, and he kept holding out for more money. But yeah, so he sold the thing. But they had an Android version and an Apple version on the app. And then when Apple bought it, they put the kibosh on the Android version, of course, and stuff. So he works for them now. Part of the deal was he had to work for them for 3 years. But yeah, he was a physics guy, which he didn't learn anything about weather, but that didn't stop him from doing a weather app.
Well, and I think that's one of the things about STEM. If you major in any STEM field, really, you can go from one to another. I was not a physics major. I was a biomedical engineering major in college. And did I work as a biomedical engineer? Not initially. They had me doing computer science at the first company I worked for, designing computer systems. So, and they just said they loved the fact that as a STEM person, you're able to learn a lot of different things very quickly. And you can go back and forth. It really doesn't, you're not always tied into one thing. So I don't know, but you ended up doing what you went to college for, which is pretty cool too.
Adam was a blacksmith for a while after he got his physics degree. So yeah, he really switched around, but.
The dog just does not want to stop. So again, I apologize. But yeah, but I didn't know he was physics. I knew he went to RPI.
Yeah.
We have a lot of RPI people in our family. So
yeah.
Anyone else? All right. Well, thanks, folks. I'll see you in 2 weeks. Okay.
Have a good night, everybody.
Thank you, Donna.
Thank you.
Thank you. Oh, Ms. Fumoso, can I stay on
Tyler.
for a second? Oh, okay.
Let me stop the recording. Hold on.